Hello, my learners. How are you? I welcome you to this wonderful lesson that we have. Okay, so today in science paper one, which is particularly physics, we are looking at uniform acceleration, linear motion. Okay, these are the questions that I've sampled from different past papers. Remember, we are here actually to give you the skills on how to answer examination questions, and this is what we are doing. So now, these are the questions that I've sampled. So question number one, a car traveling at 10 meters per second accelerates at 2 meters per second squared for 3 seconds. What is its final velocity? That is question number one. Then two, a motorcycle starting from rest acquires a velocity of 72 kilometers per hour in 5 seconds. What is its acceleration? Okay. Then B, how far does it travel during this time? Okay, so now how are we going to answer this question? What is it that you are supposed to know for you to proceed with these type of questions behind me? Okay, so first of all, I would encourage you to say you have to master three main formulas, okay, that you may use to answer this question. One of them is one, velocity is equals to final velocity is equals to initial velocity plus acceleration times time. Then 2, final velocity squared is equals to initial velocity squared plus 2 times acceleration times distance or displacement. Then 3, displacement is equals to initial velocity times time plus 1/2 acceleration times time squared. Okay, so these 3 formulas that you have seen on the chalkboard there, they are very, very important to know. Okay, so they are very important to know these 3 formulas. So now, having known this, remember first of all, before we proceed, let me tell you now the meaning of each letter. So we are going to start with V. V is final velocity, U is initial velocity, plus A is acceleration, T time. Then this one I've already mentioned, it's only S, which is displacement. Okay, so this one is displacement or distance, okay, which is measured in meters in this case. So now let us go back to the question and see how we are going to apply this same formula that we have. Okay, so we are going to start. A car traveling at 10 meters per second accelerates at 2 meters per second square for 3 seconds. What is its final velocity? Okay, so now it's you now to identify the formula that you are going to use. Which one out of those? Now, for you to select the formula, first of all, you should see what is made available there. Okay, what is given there. If we look at this statement, acceleration is given, time is given, velocity is given. Okay, so it's very easy that we can find the final velocity using the first what? The first formula. So let's say final velocity. First of all, let us correct data. Okay, very important. Data correction in physics. So we are saying acceleration. What are we given? 2. Okay, acceleration 2. Then what else are we given? Time is there. Time in 3 seconds. Okay, seconds. Then what else are we given? We are given initial velocity, because here they are saying a car traveling at 10 meters per second. So this is initial velocity. So initial velocity is 10, okay, meters per second. Okay, so we have identified what is made available there. So what has just remained is to find the final velocity according to the question which they've asked us. Okay, because they are saying what is its final velocity. So now for final velocity, this is where now we are going to introduce the formula. Final velocity is equals to the first one, that one, okay, initial velocity plus acceleration times time. So we are going to substitute now. So where there is initial velocity we are given. That's the importance of collecting data, because when you introduce the formula, you just get back to the data and get, okay? Just get. So for this one, we'll get 10, okay, plus acceleration, what do we have? 2. There is 2 there, times, what is that? 3, okay? So when we say 10 plus, remember order of operation, we are going to multiply first. So 2 times 3, that will be 6, okay? So 10 plus 6, that is it, 16. So velocity, remember, when we are looking at the SI units for velocity is meters per second. Okay, so it means we've answered question number 1. Okay, so the final velocity is 16 meters per second. Then we come to question number 2. A motorcycle starting from rest acquires a velocity of 72, okay, kilometers per hour in 5 seconds. Okay, so again here we can correct data because the question says what is its acceleration. So first of all, the formula for acceleration, we know that this is 2. Acceleration is equals to final velocity minus initial velocity over time taken. Okay, because acceleration is the rate of change of velocity with the time. So now we can correct data for this one again, for this statement. What are we given here? Here we are given the initial velocity. Initial velocity is equals to 0 because they are saying from the rest. This motorcycle starting from rest. So when you started from rest, then the initial velocity is going to be 0. Okay. Then what else are we given? We are going to see that we are given the final velocity, which is 72 kilometers per hour. Remember this one, we are going to convert it now into meters per second because velocity is always measured in meters per second, not kilometers per hour. Okay, so we have to convert this one, and I taught you how to convert. Okay, I taught you. Okay, in the previous class that we had. It's very important to be following those this lesson that I'm giving you because it will be helping you. Remember, physics, mathematics, chemistry, these are involved what? Calculations are involved. So where calculation is involved, it means it is interrelated. So once you understand this concept, it will help you to answer the other, okay, or rather the next step. So like here, if you know how to convert this, like I taught you last time, it will be very easy for you even to convert here because you have to convert that one. Yes, so now what else are we looking for? We are given that, then time is also there. Time is equals to 5 seconds according to the statement that we are given. Okay, so now from there, it's very easy for us now to find acceleration. Okay, so final velocity is 72 kilometers. How are we going to convert? Remember, we have to say 72 kilometers, how many meters make a kilometer is 1,000. So 72 times 1,000, that would be 72,000. Then we come to hour. How many seconds make an hour? 3,600. So when we say now 3,600 into 72,000, because this is the divide, this one, okay? So we are going to say over. So when we say 72,000 over 36,000, we are going to have 20. Okay, so 20 meters per second. Okay, so this is now 20 meters. It's the one that we are going to use, not this in kilometers. We have to use the one which is in meters per second. So now, where there is final velocity, we know that it's 20. So we are going to say 20 minus initial velocity, it's 0. It's there. Just have to get it. Over time is what? 5. Okay. Then from there, you say 20. Because 20 minus 0 is 20 over 5. What will be the final answer? 4. Okay, because 5 into 20 is 4 meters per second squared. Remember, this is acceleration. So acceleration is meters per second squared. Okay, you are done for A. Okay, that is A. Then we come to B. Data is already corrected there. They are saying how far does it travel during this time. So now, how far, that is distance, okay, or displacement. So we get back to the formulas. So which one can we use? You can either use this one because there is distance there, where you are going to make this S the subject of the formula. Now it's better we just go direct to this one because it is already the subject. So we are going to say S is equals to that one, okay? So initial velocity times time, then plus half acceleration times what? Time squared. Okay, that is the one we are going to use. Now let us substitute according to the information that we have. The initial velocity is what? 0. So we are going to say 0 times time is 5. Okay, plus half. We know here we have 1 over 2, which is half. Then acceleration we have found 4. Okay, so we are going to say times 4. Then times time is what? Time is 5 seconds. So 5 squared, because there is a square there. So we can write 5 squared. Then from there, let us simplify. This is 0 times 5, it's 0. So we are going to remain with 1 over 2 times 4. So 5 squared is 25. Okay, it's 25. So times 25. So now from there, we are saying 1 over 2 times 4 times 25 is times 100. So 2 into 100 is 50. Okay, so we are saying 50 meters. Because distance is measured in what? In meters. So that will be our answer on that one. It means we are done and we have scored all the marks that we are supposed to get from here. Thank you so very much for paying a particular attention. Let us continue actually. Be consistent and go through the work every time. Thank you so very much.